здесь нам как раз потребуется, наверное, техническая помощь с переводом. Обращайтесь к нашим коллегам, если что-то непонятно, как с этим пользоваться. Я приглашаю сюда главного научного консультанта Airbus Group Jean-François Geneste. Прошу, давайте поприветствуем нашего коллегу.
Good morning, everybody. I'm very proud and pleased to be here. I'm going to give you 3 small talks in about 1 hour. And the first one, I was asked to do this, so I'm going to tell you a bit who I am, and being the chief scientist of a big group in aerospace. So I'm trying to see, yes. So the job did not exist formerly. I was, when I was a young guy, I met the chief scientist of where I was working. I've been working in aerospace for 31 years. After 2 weeks, the guy died in a motor accident. But this was my dream to become this. And it was a bit painful because the job did not exist after the death of this guy. Because generally such a job corresponds to some specific personality of someone, and if there is no one, there is no one. So I had to prove, first of all, that such a job was useful in a big industrial group, and thank you very much. And so maybe the best, rather than telling you a lot of things about that, is to show you what I did along the years. So first of all, I began my career in working on missiles, then on satellites and network-centric warfare. So a lot of defense stuff. And then finally, I went to civil with planes, helicopters, and launchers. Launchers are a bit tricky. This is not really civil, and this is not really military. It depends. So what did I do? Industrial activity. So I designed an airship, 1-ton payload at 7,000 meters altitude with an autonomy of 40 days at 60 kilometers per hour. So no fueling in this. And this is for basically the observation of the battlefield and the relay telecommunication for military and also for civil, because if you fly the same airship at 1,000 meters altitude, you have 7 tons payload, and you are cheaper if it's a drone than road transportation. Second thing is tested stratospheric platform at 40 kilometers altitude. So this is a big platform which is several kilometers diameter, kind of a cylinder. And there is a lift to go upwards, so you take the plane, you use the lift, and this is a runway for high supersonic planes, basically Mach 3, which puts you at about 3 hours of any place in the world. For defense, of course, this is trivial. The platform can allow you some observation and relay telecommunications. And you can also kill the other satellites, because from 40 kilometers altitude with power lasers, you don't have any problem with air, and you can kill anything you want. So then, for a new hybrid electric plane, 20 seats, for aerial metro, you know that one of the big problems in the upcoming decades are what we call megacities, several million, tens of millions of people. And everything is crowded on ground and underground, so you need to go over this. And you need to have very safe, reliable, non-noisy planes to transport people, as many as metro, for example, and for cheaper if possible. And this is possible. A new concept of constant volume combustion engine. You know, if we, instead of constant pressure, if we burn constant volume, basically, theoretically, we save 30% efficiency. So I elaborated a new concept of engine, and the very first simulations showed that we would achieve easily 20% efficiency improvement for the engine. Then a new concept of infinite impulse space propulsion. This is not the EM drive. This is another concept. You know, specific impulse means in some way the measurement of how much mass we eject outside to be propelled. There is no physical law of physics which says that we need to expel something to be propelled. Okay, and this is about this, and this will be tested in the upcoming months this year, 6 first months of 2018. An alternative solution for electric generation on board telecommunication satellites, which we did with the European Space Agency. Basically, instead of using traditional solar cells with gallium arsenide for space, which is very expensive, the idea is to use a concentrator and use a thermoacoustic engine. Thermoacoustic means that we transform heat into solar light into heat, heat into sound, and sound into electricity. And we get global efficiency better than gallium arsenide cells on the one hand, and we cut the price of the solar arrays by a factor of 10. And for a little bit less mass for the same power. So I had also academic results. So the new post-quantum public crypto system, which can be turned into a zero-knowledge proof of knowledge in one round in the sense of Shamir. So maybe it's a bit specialized, but I presented this last April in Paris and in Poland also last June. I was invited. A new protocol of untappable quantum communications, which is based on a new axiom of quantum physics, which has been discussed at Institut Henri Poincaré in Paris. A disruptive architecture for an NP-complete capability analog quantum computer. I presented this in 2014 in Santa Barbara in the US at the Conference of Cryptology. Non-Archimedean physics, which I'm currently developing with a new model of universe with inflation without the need of dark matter or dark energy. A new model of the atom with consequences of high temperature superconductivity. I shall give a talk with Shuji Nakamura, who was awarded the 2014 Nobel Prize of Physics in Osaka next March on that. I discovered some very contradictions in the foundation of physics, basically between quantum physics and classical one. An axiomatic view I developed of what energy is, linked to information, and a new theory of systems with the goal to resist intrinsically to terrorist attacks. This will be my last talk today. So basically, these are what I did as a chief scientist of Airbus along the years. I think this is better than any speech telling you in what it consists in.